AOPS number theory 7.10. How many perfect squares less than 500 are divisible by 8? So perfect squares only have even exponents if it's greater than 0 in their prime factorizations. So since 8 is equal to 2 to the power of 3, it has an odd exponent, which means all these squares that are divisible by 8 must also be divisible by 2 to the power of 4, which is equal to 16. So we can write all the perfect squares as 16n squared. So 0 is less or equal to 16n squared, which is less than 500. So if we divide by 16, we have 0 is less or equal to n squared, which is less than 31 and 1 over 4. So then if we take the square root of this inequality, it will be, since it's irrational, it will be 5 squared is less than 31.25, which is less than 6 squared. Since 31 and 1 over 4 is equal to 31.25, it's in between 5 squared and 6 squared, so instead we could write it as 0 is less or equal to n, which is less or equal to 5. So there are 6 perfect squares, because 5 minus 0 plus 1 is equal to 6. So there are 6 perfect squares less than 500 that are multiples of 8, and that's when n is equal to 0, 1, 2, 3, 4, and 5. AOPS number theory 7.12. For how many positive n is n squared minus 3n plus 2 a prime number? So n squared minus 3n plus 2 can be factored into n minus 1 times n minus 2, and a prime number can only have one divisor greater than 1, and that's itself. So the smaller of these two factors must be 1, so that means n minus 1 is 1. N minus 2 is 1 because n minus 2 is smaller, so that means n is equal to 3. And that's the only solution possible, so the number of positive n's is 1. AOPS number theory 7.14. How many 4-digit integers are multiples of 15, 20, and 25? So an integer that is a multiple of all of these three numbers must be a multiple of their LCM. And the LCM of 15, 20, and 25 is equal to 300. So any of the multiples of the LCM of these three numbers can be written as 300n. So since it's a 4-digit number, that means 1000 is less or equal to 300n, which is less than 10,000, so that it's a 4-digit number. So if we divide each part of the inequality by 300, it will be 10 over 3 is less or equal to n, which is less than 100 over 3. So if we make it a whole number or integers, 4 is less or equal to n, which is less or equal to 33. So the number of numbers in total is 33 minus 4 plus 1, which is equal to 30 integer values. So there are 30 4-digit numbers that are multiples of 15, 20, and 25.